So we continuing with the vectors as I was mentioning a little while ago. I didn't realize I didn't click on the record button. Last week I showed you guys how to find the resultant vector, and I was writing in this column matrix to give you guys values to kind of give you an idea in terms of how to find them. What we're going to do today is build a bit more on that. So I'm talking about position vectors and prevectors, and I'm going to use the graph here to kind of demonstrate or illustrate what I was talking about. So on our screen, there are three vectors. There's one in purple and two in red. The two in red are what we call position vectors. Position vectors, if you notice, both of them, I'm referring to them as position vectors, and they both start from the origin, right? They both start from the origin. So look at where the starting point is. Let me just get my writing tool. Use my disappearing pen. And we will use pink. So look at where they're starting from. The origin is that point on our graph where we have the two axes intersecting, and that point there is 0. Right? So all position vectors, they start from that 0 point and then they project outwards. It could be to the left, even if we had another part of the graph here, they could go that way I said to the left, but I meant to the right. As A and B, they're going to the right. They could go this way, they could go down, they could go this way, right? It doesn't matter. So long as they start from that origin, we call them position vectors, all right? Now, the first letter in position vectors, because they're always starting from the origin, is usually O. So that's another way you could identify position vectors, because sometimes they may not draw the graph for you. They might just start a question and say, well, we have two vectors. The vectors is OA, and the other vector is OB, right? The mere fact that it's starting from O is a clue or indication that it's a position vector. Now, you remember when we were looking at like the size of the vector, and I was telling you guys, well, when you want to find the magnitude, you check the number of blocks this way and the number of blocks that way. Well, now we're going to build a little more now. So this position vector OA, O to A, right? This position vector here. Now we're going to change pens. So my position vector O and A, right? We could define this by a column matrix. And the column matrix is going to look at the horizontal movement across our x-axis, that's going to go on top, and the vertical movement along our y-axis, that's going to go to the bottom. So OA, because it's on a graph, we could actually check, right? Look at it. It starts at O, and to get to A, if I'm to use a different color here, look at this. If I just drop down, bam, 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 bam. It stops at 5. So 0 to 5 is 5 units across. And that's our X value here in our column matrix. And it goes without saying that, well, if that's the X value, then and my Y value, if we go across here to my Y axis, it starts from 0 and it goes all the way up to 6. Then my Y value here is going to be 6. Does that make sense? So the vector OA could be defined as 5, 6. Is everybody okay with that? Just drop a Y in the chat board if you are. Quickly, so I know that you're fine with that. Yeah? Okay. Great, excellent. So I'm gonna ask you, can you do the same thing for me and tell me what is the vector OB? What is our vector OB? Right? Remember, you want your X movement this way and your Y movement that way. So if I could just help you a little bit here. For B, you're gonna look at going across this way. All right? So that actually lines up there. And then this way. This lines up there. So could you tell me what the vector OB is in our column matrix? You could write it in the chat. Or you could use your mic. If you're writing it in the chat, write it like this. Whatever X is and whatever Y is like that. I'll understand. Right, that's correct, Lakari. It's gonna be 5, 2. Right, let's look at some more. Other page, and I wanna get some boxes like so. Right, I want to do so. Right, and so, oops. Right, so this is my Y, this is my X, this is the 0.0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. All right. And then we're gonna do some as 1. It's 1 more. Right. And we'll do this. Oops. All right. So all of them starting at the origin. This is A, B, C, D, E, F, G, H. All of them starting at O, the origin, right? So I'll do the first one for you. If I want to write all of them, we're going to express right? So if I want to do O, A, all starting from the origin, so you write O and put a little arrow there, right? We look at the coordinates of this A. The coordinates of this A is 4 and 5. Can everybody see that? It's in line with 4 there and it's in line with 5 there. So we could just read those coordinates off, and now it's going to get us our values for X and Y here. This is going to be 4 and this is going to be 5. I'd like you to do the same thing for OB, OC, OD, OE, OF, OG, and OH. Yeah, can you guys do that for me? So you're going to give me the column matrix for each of these position vectors. And like I showed you with the example, it's as simple as looking at the endpoint. The endpoint in my example was A. And if you could identify the coordinates of A, 4, 5, then you write that as a column matrix. So you put the X on top and the Y below. All right. Can you put them in the chat for me? So you just write OB and you put your brackets on and you put the values there. I understand that it's supposed to be vertical as opposed to horizontal. Yeah. So that's our first little activity, labeling position vectors. So while you're doing that, just to remind you, position vectors always start from the origin. And because of that, the first letter is always O. So that's how we could identify a position vector. A special type of vectors, so they always start from the origin. Because of that, the value, right, of the column matrix is always equal to the coordinates of the endpoint of the vector. So we saw with OA, the column matrix for the vector O is actually the same as the endpoint A. Yeah. Very good, Solana. That's correct. 8, 4. Good. Remember the X value comes first. Right. Finish that up for me. So I'm going to write them in. So OB, right? Remember I said just look at the endpoints. The endpoints of B here, if we look down, that's 8. And across, right, is 4. So the vector OB, the position vector OB as a column matrix is going to be 8, 4. For OC, right, my X value here is 4. My Y value across on the side here, look at where it's coming across to -3. Right, so on this quadrant of our Cartesian plane or the graph, the X is going to be positive and the Y is going to be negative. This one here, this is actually -7 long here. Right, this is going to be 2, -7. Right, OE is going to be -3, -3. OF is actually -9 and -3. Yep, that's correct. Very good, Julia. OG, right here, my X is going to be negative and my Y is going to be positive 2. And H is going to be -3, 5. Yeah. Right now, don't mix up your X and Y's, right? Remember, you're reading off the X first. I think you make a mistake with the last one there, that H, OH. D, where's D? OD. Yeah, 3. I have 2. Yeah, sorry, misread that. Very good, Solana. Good job. Thanks for pointing out. Yeah, in line with 3 and -7. Right, any others? 4, -3, 9, 4, -3. Okay, everything else looks correct. So that's how we label our position vectors, right? So you guys understand that. Right, free vectors now. Now free vectors, we could find free vectors by doing this, right? It's not attached to anything, this vector PQ. But if I take the coordinates here, the coordinates of P is gonna be 1, 7. Right? And the coordinates of Q is gonna be 6, 6, 4. Right? And we're going in that direction P, Q. right? What we could do is we could take our 1, 2, 3, 4, 5. We're gonna take, because it's PQ, this is how I tend to remember it, right? I'm gonna take the coordinates of the endpoint Q, right? Which is 6, 4, right? It has a column matrix. And I'm gonna subtract the starting point 1, 7 from it. So it's the endpoint minus the starting point. And I determine the endpoint and the starting point by looking at the direction the arrow is going. You see the arrow going from P to Q, and then we subtract. 6 take away 1 is going to be 5, and 4 take away 7 is going to be -3. And it would make sense because we are traveling 5 across, but we are going 3 down because of the arrow. Does that make sense to you guys? Drop a 1 in the chat board if it does.
So can you repeat, please?
Yeah, no problem. I want to do it in a, let me do it on another page. So boxes, draw, shapes, line. So 0, 1, 2, 3, 4, 5. Right, and then I want to draw some vectors, right? So this one here, whoops. This one here, this one here. So I have just a couple free vectors, right? Because they're not attached to any origin, so to speak. Wrong direction. I wanted to go the opposite way. And let's label them. So I'll label this one AB. I'll label this one CD. This one is EF.
Excuse me, sir.
Yeah?
So it doesn't have to start in the middle, right?
Nah, that was position vectors. So this one we're looking at is a different type of vector. These are called free vectors. So the one we did before was position vectors. Position vectors always start from the middle. This is free vectors now. So we're looking at position vectors and free vectors, and we're learning how to write them as a column matrix. So the position vectors, because they all start in the middle, right? You notice that they always start with O, OA, OB, OC, OD, and the vector, the column matrix of the vector is always equal to the endpoint. That's how you identify those just now. This one, and I'll call this one free vectors. This one we call position vectors. Right, so the free vectors, they just random anyway on the page. Right? Call this one xy, or yx rather. This one t b, and this one rs, and this one wx. Right? So what I want to do is I want to show you guys how we're going to write these now, how we're going to find what AB is, what CD is, what EF is. Now you have to look at the direction the arrow points in. This one is GH. This one is TV. This one here is actually YX because it starts at Y and points in the direction of X. This one is RS. And this one is WX. So for free vectors, you take the end point and you subtract the starting point from it. Right? So let's look at AB. A, B, my end point is going to be B. And my starting point okay. Just a sec. No, just freeze on restart. Let's see. Right, good. Right, back up. Right, so our end point minus our starting point. For AB, our end point is B, because look at the direction the arrow points in, right? It's going upwards towards B. Are you guys seeing the screen back up? No? Right, seeing it now. Good. Right. Our end point is B, right? Because that's where we end. And look at the direction the arrow points in. Our starting point is A. So the end point is B, starting point is A. What is the coordinates of B? The coordinates of B, if I look at this here, is 4. Always remember X first, Y after. Right? 4, 5. A has the coordinates 1, 3. So we write these as column matrices. B is 4, 5. And A is 1, 3. And then we subtract them. 4 take away 1 is going to give me 3. 5 take away 3 is going to give me 2. So my vector AB is 3, 2. Now look at this as well. If we look at the movement across, 1, 2, 3. And if we look at the movement down, 1, 2. See that? So it is in line with what we just calculated. Did everybody see that? Let me do another. Let's look at GH. You okay with that, right, Solana?
No, sir, can you please do it over?
Yeah, I'm gonna do GH now. So look at GH, right? We starting at G and going to H. The endpoint H, if I just map the coordinates of H is in line with 4 here. And if I go across here, -3. Right? I'm gonna put that in a different color. H is 4, -3. G, right? Look at G. G is 2, and come across -5. So if I want to find the vector GH, right? Because it's a free vector and it's not starting at the origin, you take the end point and you subtract the starting point from it. My end point, if you look at the direction of the arrow is going from G to H. So my end point is H, and my starting point will obviously be G. I write the coordinates of H as a column vector. So 4, -3 is what H is, minus G is 2, right? The G here, 2 minus 5. So what I have 4 minus 2, and I have -3 minus -5. Right, well, 4 minus 2 is easy. We're gonna get 2. But -3, and then this is going to be minus 5 is going to be +5. So -3 plus 5 is actually going to give us what? 2. So my vector GH is 2, 2. See here? And if we look at the movement across, that's 2 blocks that way. And if we look at the movement up, that's 2 blocks that way. So it's still in line with what we would usually use in terms of counting. Remember when we did 3 vectors initially, I was just trying to count the blocks. Right here, we actually putting it on a graph and we're looking at working it out using the endpoints and starting points. Is that a bit clearer for you guys now? Drop a Y in the chat board if you understand the concept of working out the 3 vectors. You have a 3 vector, meaning that's just drawn on a graph page, and you want to work out what the vector is: W to X, R to S, A to B, C to D. Barry, Julia, Leo. All right, excellent, good. So can you just do the others for me? C, D, E, F, T, V, Y, X, R, S, and W, X. Do those for me. We'll call those for me, and then we can move on. Let's correct these. I just wanna take off these colors off of here before we start. Were you all okay in terms of doing them? So, right, I seen Julia saw WX. Right, -3, good. Solano. The carry got through. Let's correct them on C. So the coordinates of C here is 5, 4. Coordinates of D here is 8, 1. Right, if we do CD, the endpoints here is gonna be, let me just write the answers. I only do the answers, right? So endpoint is 8, 1, beginning is 5, 4. So 8 take away 5 is gonna give me 3 here. And then 1 take away 4 is gonna give me -3. Right? So 3 across and 3 down. Right? EF is gonna be 8 take away 3 is gonna give me 5. And then we're going to have -3 take away +1. So you're gonna get -2 this way. -3 minus -1, and that'll give us a +1. Right? So I just taking off these extra stuff here, so there's not too much numbers all over to confuse everything, right? I just put the answers. You already know your endpoints from working it out. This one was 3, 2. Right? Yx, we're going to have -9, be -9 to endpoint, -5. So -9 minus -7. So you get -2 here. Right? And then below you're gonna have -5 minus -2. So it's 5 plus -5 plus 2. You can give us -3. Right? TV, the endpoint is V, which is -7. Right? And starting point is -3. So it's gonna be -4. And then underneath here, we're gonna have endpoint is -1, right? Minus 4. So that's gonna be +4, it's gonna be +3. Right? That's why it's important to do the endpoint minus the starting point, because if you're trying to work it in your head, sometimes you might make a mistake. Right? Endpoint S here is going to be -8 and 2. So -8 minus -6 is going to give us -2. And this is in line with 2. 2 minus 4 is -2 as well. This one, Wx, x is the endpoint, -7 minus -2. That's -5. And then x is the endpoint. So we're looking at 6 minus 3 is 3. Yeah. VT is what you wrote there, Julia, is correct. VT would be 4 minus 3. But we want TV. So it's the other way around. So you're not wrong. Just answer the opposite direction of what we did. Let me see some of the other things. You understand with the XY would be 2, 3, but you had to look at the direction of the arrow, right? So they wanted YX, RS, right? So you got it. You got the -2 for RS, WX -6, 3. Did I do something wrong there? X is -7, and it started at -2. So I think you're just off by 1 for the WX, Julia. Let me see, EF, 5 minus 2. So remember, Solano, you would have done for EF. 5 is correct, but it'll be -2. A good way to remember, guys, if it is you're moving to the left, then it's going to be negative. And if you're moving down, it's going to be negative. So look at this, right? Look like with EF. EF is starting here at E and going to the right. It's going to the right 1 time, 2 time, 3 time, 4 time, 5 time. That's why this value here is a positive, right? And then look at it. It's going down. It's going down 1 time, 2 times. And because it's going down, that's why this is negative. Again now? So it's always endpoint minus the starting point. And if you just want to double check your answer, you could look at it like that. Look at this one, CD. CD is going across this way. 1, 2, 3. That's why this is 3, right? And then it's going down towards CD. 1, 2, 3. That's why this is -3. Seen it? What's another one? Look at the TV. TV is going up, right? Or across. So it's going left. 1, 2, 3, 4. Because it's going to the left. To the left is -4. See it? But so it is going up. to V. So it's going up 1 time, 2 times, 3 times. That's why this here is a positive 3. You all understand it now? Silano? Bakari?
Yes, sir.
Yeah? All right. So we only have to do this with 3 vectors. So all we did really on the graphs is just learn how to label or identify 3 vectors and position vectors using column matrices in this form, X, Y, right? So we saw how OA was 5, 6, and OB was 5, 2. That was these 2 that we did before. And we learned how to work out PQ, right? So next, we want to talk about adding and subtracting vectors. So sometimes, you know, you get a question and they could define vectors. They could say the vector U is OA plus OB. And we could add vectors together like that, right? So OA from what we did before up here, OA was that vector, and I'll just write it in. Let me just write them in one time. So it's easy for us to remember. Number 5 and 6. Oops. And OB was the vector 5, 2. And PQ was the vector 1, 2, 3, 4, 5, negative 5. And 1, 2, 3, negative 3. Sorry, 5 and negative 3, not negative 5, because it went to the right. Right? So they're coming back with them same things here again, all right? Remember OA and OB. So they're saying that there are 2 vectors. There's a vector called U and a vector called V. And U is such that it is equal to OA plus OB. So all we're doing is we adding those 2 vectors that we have already identified above as 5, 6, and 5, 2. So we get a new vector when we add those 2 together. The vector U, which is 10, 8. Vector V, we could subtract vectors as well using our same thing we do with matrices, right? So we say V is OA minus OB. OA is 5, 6. And if you minus 5, 2 from it, we get 0, 4. So we have 2 new vectors altogether. We could also multiply vectors. So we could say there's another vector called W, which is equal to 3 OAs. So it's 3 times the length of the original OA. So this new vector W is 15, 18. Or we could say, you know, there's a vector W, right? Just using W again. That is half of OA. So it's half the size of OA. And we just find half of 5 and 6. So we get 5 over 2 and 3, right? We could then define vectors such as Z, which is now equal to half of U. Remember, we found U above. U was 10, 8 minus 3V. And we could work that out. U was 10, 8. Look at it here. And V was 0, 4. So since Z is equal to half U minus 3V, this is like vector algebra, right? You just find half of the 10, 8, which is 5, 8. You multiply the contents of V, which is 0, 4 by 3. And then you subtract those 2 and you get this new vector altogether called Z, right? So this is an example of what we call vector algebra. And it's just like a big callaloo pot with, you know, the vectors, all the things we learn with vectors, a little bit of matrices with column matrices in there, and then some algebra. And they just toss all that up in a pot and they kind of mix it up. And this is what they come up with. But it's not alien material to you. You know all of these things. You know how to add matrices, right? You understand the concepts that I've taught you with vectors, and well, you know algebra, right? So 3K, if K was the number 4, then 3k is 4 by 3, or 3 by 4, which is 12. Make sense? Does that make sense to you guys? Yeah? I could go on, right? Okay, good. Nice. All right. Add some more content. Let me go again. Let's look at a question. Now look at this. The diagram shows two position vectors. We have the position vector OA and OB, right? And there's also another vector called AB, right? Can you work out for me in column vector form, right? What are the values for OA and OB for me? Based on what we learn with position vectors. Position vectors, you would always identify a position vector because it starts with the letter O. So that means that it starts in the origin. And once you identify that it begins with that O and it starts in the origin, remember when you're writing the column vector, the column matrix fit, all you really need to know is what are the coordinates of the endpoint. All right. So write the column vector for OA and OB for me. Can you guys see the numbers on this? Do I need to make it bigger? Yeah.
Is it the same thing like with when you have to subtract the n from the beginning?
No, you would subtract when you're doing free vectors. So a free vector would just be an arbitrary vector like in the middle of the page here. Right? And if this was xy, then you would have to subtract. If you want to subtract, you can, but you'll just be subtracting by 0, 0 all the time. That's why you don't need to subtract, right? You just look at what the endpoint is. This endpoint here is 5, 2, right? So even if we subtracted, right, Solana, the subtraction will be endpoint minus starting point. You can if you want, if it would make you feel a little more comfortable. You're starting in the origin, which is 0, 0. So guess what's going to happen? You just get, plus 5 takeaways, you're going to give you back the 5. 2 takeaways, you're going to give you back the 2. So you could either do that, or you could just read off what your endpoint is because it's a position vector, and the starting point is always going to be 0, 0. And if you subtract 0 from it, then it's just going to get back itself. Make sense?
Yes, sir.
So that's the answer for OB. So find OA for me. And then we're going to do AB. And to do AB, we're going to learn some. We're going to use,
one more thing.
yeah.
Where you get the 2 from?
The 2.
No,
oh, you seen it, right? Yeah, it's in line with this 2 here. Remember from what we learned before, AB is going to be AO plus OB. Remember that from last week? And if we know what OA is, right? If we want AO is negative OA. So whatever OA is, you're going to put a minus sign in front of that and change the values of it. So now once you have that, you can add those two together to work out what AB is. Right, so work out what OA is for me. After you work out what OA is for me, I want you to find AO. AO is negative OA. It's the opposite direction. Right, so you just put a minus sign in front of the brackets for AO. Sorry, for OA. Right, and that's going to give you what you're looking for there. And then you're going to use our triangular law of vectors to work out what AB is. Right, good. Julia says that AO is -1 and 3. And that's correct. Very good, Julia. So if I want to change the direction of OA, because for me to find AB, I need AO minus OB. But I didn't get AO. So to get AO, I'm just reversing the direction of OA. You understand? And to reverse the direction of OA, this is what you do here. You just put a minus sign in front of it. So minus -1, 3. So AO is actually going to be a minus by a minus here will give me a plus, and a minus by this positive 3 will give me a minus. So AO is 1, -3. OB will work out to be 5 and 2. So AB is the sum of those two. 1 plus 5 is 6, and -3 plus 2 is -1. So AB is -1. Does that make sense to you? Let's drop a wife. That,
Yes.
yeah. All right. So this one is position vectors with triangular law vectors. We want boxes, please. And we need a graph. I'll take a red axis. The blue numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Good. We'll do some vectors now. Position vectors. So let's say we have one going there, and another one going this way, and this is oops. Well, we know this is O. We call this C, and this is D. So find OC for me, find OD, and then find CD for me. Right? So OC and OD are position vectors. CD is where we're using our triangular law of vectors to work out. So CD, right? If I may, this is OC and this is OD. If I want C to D, right? I want this. As a resultant vector that I want, C, D. Just like that analogy I'll give you with the QREP thing, right? To go from here to here, which is like Shogunas to Town, I could also go from Shogunas to QREP this way, right? Pretend this is QREP here. And then stay from QREP and go to Town this way. Now that's fine, and that will accomplish starting at C, going to O, starting at O and going to D. So I'm still gonna start at C and end at D. My common point in the middle, which is the QF junction, is going to be O. The only thing with this now It's unlike the questions you was doing before. We want to go in the opposite direction of the vector that we were given, because they told us, if you look at the red arrow, that this vector was OC. So if you want CO, CO is actually negative OC. CO is equal to negative OC. We could change the direction by putting a negative sign in front of the OC, and that reverses the direction and gives us the CO. You understand that? Right? So these two here are position vectors, which you would use what we learned today about the endpoint. And for position vectors, the column vector is always just the coordinates of the endpoint. This is from last week with our triangular law of vectors, where I said always write it C, D, and then you put any common point in the middle, which in this case is the O. Right? You have to come back to O to go to D. Look at it. It's the common point that is in both of them. So you get CO to OD. You want CD, so it has to start at C and end at D. Right? And there must be the same letter in the middle. The same letter could only be the O. There's no other letters in the diagram. The only other letter is other than C and D is O. So the middle letters is going to be O. The thing is that you don't know what the value of CO is outright, but you can use this value that you have here, OC, and change the direction of it to get CO, because you have the O and the C. If you change the direction of OC and you want to change that to CO, then all you're really doing is just finding the opposite direction of OC. Understand? Let's drop our Y in the chat for the field. And if you do, so I know to go one at a time. Julia, you okay with that? The carry? All right. So we're going to do it in parts. So the first thing you're going to do for me is, well, I'm going to take off some of these things I have here. Clean, 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 clean. Clean page, clean mind. Right. Oh, piece here too. Oh, yeah, right, you back. Right, Julia. So you can find OC for me, because you do that today. What would OC be? And find OD for me. So these two you could find because we do that today, OC and OD. All you need to do is look for endpoints here. Get the front column. Endpoints here. And OC and OD is going to be equivalent to those endpoints. Yeah? So type in the chat, Julian, the carry, what my OC and my OD going to be. Now we talk about CD. Right. Good, Julia. So this is 3, 4. So OC going to be 3, 4. And OD is negative 6, 3. Good. Right, so you understand that. The carry, you okay with that? The carry there, right? Yeah. Good. Now for CD, right, Julia? If I want to go from C to D this way, I don't mind I missed the line there. I just say there, right? If I want to go from C to D, instead of going straight from C to D, I could also travel this way and go to O. This is O here. And then from O go to D. So I could accomplish going from C to D by going from C to O and then O to D. Do you agree with that? Drop a Y in the chat board if you do. Right. So we know that OD, you just worked out OD. OD is -6 and 3. Right? CO on the other hand is the opposite direction of OC. OC is 3, 4. But if I want to go in the opposite direction, CO, I want to switch the arrow in the opposite way. Then I need to put a minus sign in front of this 3, 4 to get my answer for CO. You understand how I change the direction? Because look at this, right? If I'm going from O to C, I'm going up, I'm traveling up like this. So we have a movement to the right this way, 1 block, 2 block, 3 blocks, right? So that's the positive 3 there. And we're going up, right? So we have a movement 1, 2, 3, 4, right? To get up here. But what if I want to go in the opposite direction? Right? What if I want to go down instead, this way? And then to the left, this way. If I'm traveling down now, 1, 2, 3, 4, this becomes -4. Right? And if I go to the left, 1, 2, 3, this becomes -3. So that's why I say, if we want to get in the opposite direction, so if we know OC is a positive movement this way, and I want to get CO, which is the opposite direction, then I'm going to put 3, 4. Just 1 second, guys. 1 second. So if you're going in the opposite direction, that's why I say we just take the OC that we already have and we drop a minus sign in front of it, and that automatically changes it to CO. Does that make sense now? Drop a Y if it does, or 1, because you already have a Y there. Yeah? The carry, yeah? Make sense? Right. Nice. Now we're cooking like grandpa gas. All right, so I'm taking these off from here now, right? Taking these squiggles off. Take all of this off. Right, so we know what CO is here. And I'm just changing all of this. You gotta go blue now. Right? So we get -3 here now. And -4. We add those two together. -3 plus -6 is going to give me -9. And -4 plus 3 is going to give me 1. Right? -1, sorry, my bad. To move these other squigglings from it. Right? So we found what CD is. So CD is equal to -9, -1. And look, we could check it too, right? Check how we could check it. How much times you moving? Because CD is going in this direction here. Down. It's going down 1. So that's why this is a -1. I going to the left. How much times to the left? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3 there. So CD is -9, -1. That's it. So we wrap up with that. It's a lot. But like I told you from the beginning, right? We just added on top of what we already knew. Right? We saw these triangular lower vectors last day. I can still show it to you. Right? I kind of drop it in on your here. You was doing it before. The only difference is that I was deliberately putting it in a way where you don't need to change the direction. So like to find AC here, you're just going A, B, and then BC. And you had what BC was. BC was 2, 4. Right, look at this one. We did MN, NP. You know what MN? MN was -1, 2, and NP was 3, 5. Right, so you didn't have to change any direction. So we did this lastly. All we did now is that we have a little bit of extra thinking to do, because sometimes we might need to go in the opposite direction of the vector that they give us. And to change the direction of a vector, all you're doing is just putting a minus sign in front of it. So if I have the vector OC and I want it to go the other way around, like CO, I put a minus sign in front of it. If I have a vector XY and I want YX, if XY is 1, 2, then YX is going to be -XY. So I'm just going to put a minus sign in front of that 1, 2, and it changes to -1, -2. That's all you're doing to change the direction, right? Because now it's going to go to the left and drop, right? If it was 1, 2 before, that means it going 1, 2 means that I'm going across one block. This is horizontal. So I'm going across one block, and I'm going, so this is across, and I'm going up 2 blocks. So if I go in the opposite direction now, it means I have to go, well, not across, across right, I should have said, and up, right? So to the right, 1 block, that's what a +1 here means, and 2 means I'm going up. If I want to change direction, and I have to go left, so I'll go to the left, and it becomes -1. And then instead of up, I have to go down, so it becomes -2. Does that make it clearer now? Everybody? That's the last.
Yes, sir.
Yeah, and then we wrap up. All right, nice. All right, guys. So that's it. You're all doing well with the vectors. Happy with the progress you have made so far. It's a long weekend, so be safe. Don't forget that although you're seeing the rain falling and stuff, we still have we're still in a heat wave, so you wanna drink your water. Avoid the sun when it's really hot. If you do go to the beach this weekend, be careful. Right, don't go too far. I'll see you guys next week Saturday, and we'll continue with some more vectors. All right, everyone, thanks for coming out. Bye. Enjoy the rest of your day.
Bye, sir.
Bye.
Bye, sir.
Take care, Julia. Later the card.